understanding the question before I answer. Because sometimes you ask a question and I think you're asking something else. But yeah, anyways, I decided that this microphone underneath my mask, I think it catches the sound a little bit better than the webcam. So, but yeah, if there's ever any sort of things with the videos, I do want the videos to be as high quality as possible. So if you have any sort of suggestions that I can try to make some improvements, I'm totally open to that. Remember that this is all about you and your learning. So I really want to make sure that what I'm doing is working for you. So if there's ever anything that's not working, let me know and I'll see what I can do to accommodate your needs. Okay, kind of out of breath today for some reason. Not sure why. Okay, so yeah, we're on YouTube now. Let me just share the link on Discord. Here you go. There it is. Okay, beautiful. Okay, so factoring concepts. So the whole idea of factoring concepts is to take a look at why we do what we do when we factor quadratics. Okay. So this isn't going to be like a super like heavy lifting type of class. We're kind of sort of we're going to be thinking about like why we do what we do. Okay. So, oh shoot, I'm going to erase this before you see it. What? Wait, don't look. There we go. Okay. Sometimes I do the problems first. That way I'm not just making it up as I go along. But then I forgot to erase it. Anyways, any questions before we get started? No, we're good. Okay, cool. Um, so much stuff going on right now. Okay, let's get started. So let's talk about factoring a quadratic that looks something like this. So what we're going to do, we're going to use a model that looks something like this. Now, usually we don't make it like a diamond. I mean, we can make it a diamond if we wanted to. I just made it look like that so it looks interesting for the YouTube thumbnail. But really, it's going to be more something like this, something like that. That's actually kind of the model, what it's actually going to look like. Um, and this model is going to be just for our understanding and our learning. Ideally, we're not going to be drawing this picture every time we factor a quadratic. The whole purpose of this is to develop an understanding of what we do so that we know why we do what we do. Okay? There's several reasons why it's important to understand the why and not just the how. One of the reasons is that if you forget how, if you understand why, then you should be able to sort of reinvent it and recall what the process is. As well, mathematics isn't always just about being able to find an answer. It's a lot of it is being able to communicate with another human brain, that is able to sort of understand what you're saying. Oh, I guess you can kind of hear. I can hear myself. Anyways, okay, let's just jump right into this. Let's try factoring this. Let's try factoring this number here. So let's factor this. So I'm going to turn this into a question. So we're going to factor this. So in other words, what we want is we want two linear factors. Okay, so this is going to be a linear factor. Let me change colors here. Linear factors. And this is going to be another linear factor. Okay, keeping in mind that maybe it's not going to work. Sometimes it just doesn't work. We're going to explore all the different ways that this is not going to work. Sometimes it just doesn't work. I'll give you a hint though. This particular question I've already done. It does work. So we can factor this. So we want a linear factor. So a linear factor is going to look something like this. It will have a times x plus b and c times x plus d. Okay, oops, didn't mean to do that. Okay, where a, b, c, and d, a, b, c, and d are all real numbers. Okay, they're all real numbers. So what that means is that they're real numbers. Okay? And our goal is to find A, B, C, and D, right? That's what we're trying to do when we factor a quadratic, right? We want to find the two linear factors. So a linear factor is something that's in the form y equals mx plus b, mx plus b, okay? mx plus b. Okay, so these two factors, they are going to be linear. Okay, so these are our linear factors. Okay, so so going back to like a couple of days ago, we were doing we were working through this stuff. We found out how to factor a lot of different types of quadratics. So something like this, we started off something like that, 2 times x squared minus 4x plus 3, and we found the two linear factors. These are them, okay? So what we're going to develop today is a model that describes what's really happening behind the scenes here, okay? So let's go ahead with this. So what I'm going to do is I'm going to draw a rectangle. So I'm going to use the rectangle model. Okay? And the rectangle model is going to represent this quadratic in a geometric way. That is, we're going to use shapes to represent this quadratic. And we're going to use the whole idea of area. Area being length times width. Okay? So this is what we're going to do. I have to scroll down here to make my picture. So I'm going to make it nice and big. Yours can be as big as you want it to be. Keeping in mind that the whole purpose of this is to develop our understanding, and we're not exactly going to be doing this every single time we want to factor a quadratic. This is kind of like a temporary measure that helps us develop our understanding. So you might notice that I've sort of skewed the rectangle here. So they're not intended to be perfect squares, right? Because I don't want to give the impression that these are all perfect squares. So it's not like all of these have equal area. The whole idea of this is that these are all going to have different areas. So let's take a look at this. So we're going to factor 10x squared plus 17x plus 3. Okay? So I'm going to reserve a certain few rectangles for some of these terms. So we've got these 3 terms here. We've got the 10x squared, the 17x, and the 3. Okay? So let's take a look here. I'm going to put the 10x squared here, 10x squared here, and I'm going to put the, 3? Yeah, I'm going to put the 3 down here. Okay? So the idea is as follows. So what we're trying to do is I'm going to write A, B, C, and D here. Okay? So the whole purpose of this is that we want to find, well, this is actually going to be AX and this is going to be CX. So this length is going to be CX plus D. Okay? And this width right here is going to be AX plus B. So those are the two linear factors that we are trying to find, right? So we need to find what C is, what D is, what A is, and what B is. So those are the 4 numbers that we're looking for. Those are the same 4 numbers that I was talking about over here. Okay? So this is our goal. And we're using geometry and the whole idea of area being equal to length times width. Okay? So let's think about this for a minute. Remembering that we have a total of, I should really copy out that. Let me just copy out that the original quadratic. Let me copy this. Copy, and I'll paste it down here. Okay. Okay, so I've got my 10x squared, right? So the idea is that this whole area, the area of this entire thing is going to be equal to the quadratic here. Okay? So I'm trying to find out what my length and width is. Right? That's essentially what I'm doing. That's what it really means to factor something, right? It's to break it up into two different factors, and we need to know what those factors are. So we're looking for these terms. So I've gone ahead and I've placed the 10x squared here. That way I know that all of my x's are going to be in sort of like from here to here and from here to here. So that's where all my x's go. So I've got my cx and I've got my ax here. Okay? And then my constants are right over here, which means that I've got a constant here. So d is my constant, b is my constant. So I know that b times d is equal to 3. And ax times cx, that's going to give me this times this is going to be 10x squared. So in other words, I know that c times a is 10 and b times d is equal to 3. Okay? So those are some of the first facts that I know. Now, whatever this is and this is, that's what remains to be found out. That's what we need to figure out next. What I do know is I know something important. What that is that whatever this is plus this, oops, what did I just do? Whatever this is plus this, that's what 17x needs to be. Okay? So this plus this is going to be 17x. So I need to know how much of this 17x goes here and how much of the 17x goes here, right? That's really all we're doing when it comes to factoring quadratics, is we're saying, okay, how much of that middle term needs to go here and how much of it needs to go here. Okay, so let's see if we can come up with a few interesting facts. So I know that that maybe I'll do some color coding. Let's do some color coding to make this a little bit easier to see. So I'm going to use, how about I haven't used purple yet. So I know that this area plus this area, how about red? Yeah, okay. That area. So I know that this plus this, okay, so this plus this must be equal to 17x. Okay, so that's one of the things that I know. Let's see if I can find a different sort of fact that I can use to my advantage. Okay, so this one is a little more subtle, so you'll have to bear with me. You have to bear with me. Okay. Okay, let's see what happens. Let's see what happens if I do. Okay, I'm gonna highlight a few different sides here, a few different sides. Okay, so I'm gonna call this side. I'm gonna call this side. Let's say. Oh, cool. Hold on a second. I'm gonna call this side A, capital A. Okay. I'm going to call this side over here. I'm going to call this side over here. I'm going to call this side B. Okay, so I got A, side B. Okay. I'm going to call, actually, I'm going to call that one C. I'm going to call that one C. Sorry if you're finding that confusing. I'm calling it C because this is C, right? So these two sides, these are all the same length. So let's call that side C. Side C. Okay. And then that makes, I guess, this side over here. This side over here, I'm going to call this side, I think it's probably obvious, side B. And then I'm going to call this last side D. This last side is going to be called D. Okay. And I'll use this color. So this is going to be side D. Okay. So I just want to be able to refer to those sides really easily. Okay. So just keeping in mind that this side side A, these are all different versions of A. So these all have the same length, right? So that's why I called it A, because this represents AX. So this side is A, this side is C. So all of these represent the length of C. And then all of these represent the length of B, and all of these represent the length of D. Okay? So I'm just naming things, okay? So we haven't quite got to the mathematics yet. We're just kind of setting ourselves up, drawing pictures, trying to get a sense of what this all looks like. Okay? So I've got all those sides. Let's see what happens if I multiply them all together. Okay? A times B times C times D. Okay, so let's try that. So A times B times C times D. What is that equal to? Let's see if we can see what that's equal to. Okay, well, let's see. A times C. I know that A times C is x squared, right? Or sorry, 10x squared. 10x squared, right? So this area right here, this is A times C. Okay, so that's A times C. So I know that A times C is equal to x, or 10x squared. Come on, 10x squared. And I know that B times D is 3. Okay, so that's equal to 3. B times D is equal to 3. So that means that A times B times C times D is equal to 10x squared times 3. Okay. Let's see if we can do it in a different way. Okay. Well, A times, let's take a look at this. So this is A, and so is this, and this. So A times D is this area right here. A times D is that area. And then also B times C is this area right here. So let's write some of that down. So I've got, what was that? A times D. So A times D is equal to, what do we call that? Red. That's the red area. Okay. And then also we have that B times C is this area right here, the purple area. B times C, right? Because this is C and this is B. So B times C is equal to the purple area. So that's equal to the purple area. Okay. All right. So let's think about what that means. So that means that we have, okay, let me get my marker out. So this is also equal to the red area multiplied by, come on, multiplied by the purple area. Okay. So what does this all mean? What are we talking about? What is Mr. Ben talking? A times D is red, B times C is purple. Like what in the heck is this all about? So this is what I'm really trying to do. So we're trying to find a few numbers. We're trying to find a few numbers, right? So I know that when I multiply these two numbers together, okay, I'm going to get this product right here. When I add these two numbers up, I'm going to get this area plus this area. So let's have a look at kind of a method that we can do to find what those numbers are. So some people like to call this the diamond. Okay, so this is my diamond. Okay, so we write out a little diamond. And when you're first starting to do this, it sometimes helps to draw a few extra symbols. Okay, so one of the symbols, we write a little dot right here. That dot represents multiplication. And then the other symbol that we write is addition. Okay? So we got multiplication on top and addition on the bottom. Okay? So what we want is when we multiply our numbers together, we get 10x squared plus 3. Or sorry, 10x squared times 3, which is 30x squared. 30x squared. That's what's coming from this. Okay, so that's our 30x squared. Okay. However, when we add these numbers together, we want 17x. So we want what this area is plus this area. Okay. So when I add the numbers together, I want the sum of these two areas. So that's going to be 17x. Okay. So our goal now is to find out what happens here. Okay. So remembering that when I multiply these two numbers together, like A times C times B times D, I get this area. But when I add these two together, I'm going to get whatever this area is. Okay? So our goal here is to fill this in such a way so that when we add these two numbers together, we get 17x. And when we multiply these two numbers together, we get 30x squared. Okay? So you can see that we're probably not going to draw a big diagram like this every single time, but you might be inclined to draw this every single time. Okay? This doesn't take up very much room on your page, and it doesn't take very long either. So a good place to start is to think of different factors of 30. Okay? Let's think of different factors of 30. Yep. Yep. So I think, 1 and 30, that's a good place to start. So 1 times 30, that's 31. Or sorry, that's 31. Do we get 17? No. Okay, I think Hisham had his hand up first. 2 and 15. Oh, 2 and 15. Is that what you were going to say, Aaron? Okay. Yeah, exactly. So keeping in mind that it's going to be 2x and 15x, right? It's a race, isn't it? So now we know what goes in here. Okay? So let's see here. I know that I've got 2x over here, and we've got 15x over here. Now, something that you should know is that it doesn't actually matter which one goes where. You can decide that for yourself. So whichever one you prefer, like if you wanted to, you could have 15x over here and 2x over here. There's some symmetry here, so it doesn't really matter as long as you put one there. Okay. So that's kind of just like what our model looks like, but we still don't know what ax plus b is. Like we still don't know this. Could we figure it out by looking at it, or do we need to do more steps? What do we think? Do we need to do more steps? Like, are there more steps, or do you think that we can actually just figure out what this length is, what this length is, what this length is, and what this length is? Okay, what do you think? What's this length? This one here. I'll give you a hint. We don't have to do any more work. Our work here is like 99% done. It just comes down to pulling out some factors here. So I know that this is going to be something times x, right? What's the biggest factor that we can pull out of here? Yeah, or in other words, 5x. So let's call this 5x. Okay, what's the biggest factor we can pull out of here? 1. There's only one thing that we can pull out of here, which is 1. We're basically trying to pull out the greatest common factor of each of these. Okay, so now that we've got this, so we just pulled out the greatest common factor of it. Now we could either do the same thing, or if you're not completely satisfied with that, let's try to figure out if this is 5x, like if I'm saying that this side is 5x and this whole area is 10x squared, what's this side going to be? Well, if this was 5x and this was 5x, then this area would be 25x squared, right? Yeah, it'd be 2x, because the whole area is 10x squared, and one of the sides is 5x, which makes that this other side is 2x. So cx is 2x. And also, finally, if this is 1, then what is this side going to be if the whole area is 3? It's going to be 3. So we did a really roundabout way of factoring this. I know that one of the factors here is going to be 5x plus 1. The other factor here is going to be, what do we say, 2x plus 3. And we're done. Well, we're 99.9% done. Let's actually just write it down. So a nice clean page. Let me, I think I can just paste it. There it is. Okay, so this is equal to, well, one linear factor times another linear factor. What did we say it was? 5x plus 1 and 2x plus 3. Is that it? 5x plus 1, 2x plus 3. There it is. Okay, any way we could check our work? How could you check your work? Surijna? Yeah, multiply it out. Yeah, we'll use the distributive property. So 5x times 2x. So I'm just going to write check. So we'll check our work. 5x times 2x is 10x squared. Okay. 5x times 3 is 15x. Oops. 15x. 1 times 2x is 2x. And 1 times 3 is 3. Well, these are like terms. So this gives us 10x squared plus 17x plus 3. And there it is. That's what we got. You might recognize some of these numbers, the 15x and the 2x. Those are the numbers that we put here, 15x and 2x. What we're doing here, essentially what we're doing when we're factoring quadratics, is we're undoing the distributive property. So we're doing the distributive property backwards. Okay, so that's effectively what we're doing. So, yeah. These notes, I'm going to post these notes on Classroom as well at the end. So if you need to recopy something, you can. So let's do another question. This time, let's avoid the rectangle model. We'll just use the diamond. We'll use the diamond. So let me just scooch over to section 4.2. Okay, how about this one? Okay, so let's do 2u squared minus 8u plus 6. Okay. Okay. So what I'm going to do, we're going to kind of go from 0 to 100 here. You know what that means? We're going to accelerate very quickly. Okay. So I'm going to show you how to answer this like very quickly. Okay. So this is our method. I draw the diamond. I'm going to write, just for my memory, I'll write times up here, plus down there. I'm going to multiply this coefficient and this coefficient. Okay. Okay, so I'm gonna multiply these together, and I'm going to get 12. And then I'm going to put the -8 down here. Okay? So I'm looking for two numbers whose product is positive 12 and whose sum is -8. So I'm going to look. So I know that if the product is positive and the sum is negative, they both must be negative, right? Because a negative times a negative is a positive. So I'm going to say, okay, well, my factors of 12 are 1 and 12, but it would be -1 and -12. That has a sum of -13. Then that's -2 and -6. There it is, second try, right? So these are the numbers that I have. I'll write -2 and -6, okay? And I'll show you kind of a different way of implementing this rectangle method without actually writing anything down, like any kind of big picture down. We basically, what we're saying is that this is now turning into two things. This is where we split up those factors here. This is how we're splitting up these little rectangles on the side. We split it up like so. I say I've got 2u squared minus 2u minus 6u plus 6. So really what I did is I split up this -8u. Okay, let me change the color so you can really see how that's split up. What's u? Oh, sure, maybe an n. That's how I make my u's. It doesn't really matter as long as it's the same letter. So that's how it's split up. And now what we're going to do is we are going to try to factor that and factor that. So we'll take out the greatest factor that we can. In this case, that is going to be, I believe, 2u. So I've got 2u. Okay. So I factored it to 2u. And I'm left with u plus 1. Oh, yes. Thank you. U minus 1. Okay. Then I'm going to write plus. I'm going to factor this thing out. Okay. And it looks like I can factor out a -6. So I'm going to write, oh, I'm getting ahead of myself here. So the biggest number I can factor out is a -6. So I'm going to take out this -6. And I've got -6 times, well, I've got, here's a u. So it's a -6 times u. So I'll write u. And then when I factor out a -6 from +6, I'm left with a -1. And then look at that. I've got a u minus 1. I've got a u minus 1. I've got another u minus 1. So let's factor out a u minus 1. A u minus 1. And what I'm left with is 2u minus 6. And again, I'll color code this so you can kind of see what's going on here. So the u minus 1s are like these ones here. There we go. And I'll change that to be, how about green? Okay. And we're done. So this is a 4-step. This is a 4-step process. So this process takes 4 steps. Okay. So I'm going to end the video there because I don't want it to be too long. It's already about half an hour. So if you're watching the video, I'll see you next time. Bye-bye. Okie dokie.